Good morning, everybody, and welcome to Automation Alley's virtual tech takeover this morning, hosted by Markforged. My name is Allison Trumbull, and I am Relationship Manager in terms of technology here at Automation Alley. If you're not familiar, Automation Alley is a World Economic Forum Advanced Manufacturing Hub, or AmHub, and Industry 4.0 Knowledge Center. We host a plethora of events and obtain content from all over Industry 4.0 to give businesses a competitive advantage by helping them along every step of their digital transformation journey. So here we obsess over disruptive technologies like blockchain, 3D printing, the Internet of Things, and automation. Our goal is really to work hard to make these complex concepts easier for companies to understand and implement today. So if you haven't already, register for our Integrate conference. That is our Industry 4.0 conference this year. It will be a hybrid event, so in person as well as virtual, on October 19th at TCF Center in Detroit. We'll have keynotes, breakout sessions, and expo hall. We're so excited to see everybody and network in person. And don't forget, if you are a Michigan manufacturer, you do get one free ticket. So you can go to our website, our brand new website as of a couple weeks ago, and make sure to sign up there. But on to today's presentation. Markforged's additive manufacturing platform is transforming the way businesses around the world innovate. Markforged is changing the pace of innovation with the Digital Forge, an intuitive additive manufacturing platform powering engineers, designers, and manufacturing professionals all over the world. The Digital Forge platform seamlessly combines best-in-class machines, software, and both metal and composite materials to empower engineers and designers to go from a design to a functional part more efficiently. Founded in 2013 and based in Massachusetts, Markforged has about 250 employees globally, with 137 million in both strategic and venture capital. They were recently recognized by Forbes in the next billion-dollar startup list and listed as the #2 fastest growing hardware company in the US in the 2019 Deloitte Fast 500. This morning, we will be diving into the benefits of additive manufacturing with Zach Rosenwig, Customer Success Manager, and Nick Sunday, Markforged Additive Consultant. So don't forget, we will be doing Q&A at the end of today's presentation. So we do have a little chat box at the bottom of the screen. Please use that throughout the presentation to type in any questions. Like I said, at the end, we'll address any of those as well. So Zach is going to kick us off this morning with a few interviews from Michigan manufacturers, specifically Inducto, Tucker Induction Systems, and Zero Tolerance. They're going to be chatting about the benefits of additive manufacturing, technology implementation, surprises they've found, and use cases. So thank you so much for joining us today. And Zach, the floor is yours.
Good morning, everyone, and thank you for joining us. And thank you to Allison for the introduction and Automation Alley for having us. My name is Zach Rosenzweig, and I am the Customer Success Manager here at Markforged. We've got a great agenda set up for you this morning, in which we'll dive deep into the benefits and value add from additive manufacturing, beyond just the typical cost and lead time advantages. We're going to get started this morning with 3 of our customers from Southeast Michigan, and they're going to share with us their journey with additive manufacturing to date, and many of the advantages that they've uncovered. All right, let's get started.
Good morning. We are first joined by Josh Tucker of Tucker Induction Systems. Josh, good morning. If you wouldn't mind, give us a little introduction about yourself and tell us about your company.
Yeah, good morning. My name is Josh Tucker. I work for Tucker Induction Systems. We are an induction tooling company that's been servicing the industry since 1976. We provide complete induction tooling services from the design and build of new to the repair of existing induction tooling equipment, from coils to quench assemblies to locators to machines themselves. So that's pretty much us.
Wonderful. Well, Josh, thanks again. I'm happy to have you here to talk to myself and the greater audience about your experience to date with additive manufacturing or 3D printing. I know it's been not quite a year since you've jumped into the technology. If you wouldn't mind, and to start us off here, tell me a little bit about your opinions or thoughts of the technology prior to jumping in a handful of months ago.
Yeah, so prior to getting hands-on experience with additive is, mainly our thoughts geared towards prototyping, samples, nothing necessarily really functional. I guess the idea that we had behind additive manufacturing is it's a great place to start for development, but nothing that's really gonna, be visible in the field. And that's something that we're happy to say that we found different since being in additive.
Great to hear that in just such short time you've experienced so many successes. And I'd love to hear about them. So if you could tell me about some of the additional benefits that you and your company may have uncovered since getting into additive manufacturing that go beyond just cost and lead time that we're talking about today.
So for us, mainly where you start to see the biggest benefits is actually in some of our tooling, and they help with, like you said, beyond cost and lead time. You start talking about fixturing for machines and parts that we make in house that are not only allowing us to get these jobs done quicker, but it's also helping the guy running the machine. He's not there as long as he was. We do a lot of stuff manual here still, like on manual bridge ports and, time spending turning handles, standing on concrete. You start cutting that time back as far as a machinist standpoint. It's your job's easier and it's lighter work on you in the long run. So kind of being able to move through faster, alleviate some of those pain points for the machinist is huge. On top of, we noticed that there's been a little bit of how do you say, like an emotional shift, I guess is what you would call it. Everyone here is excited about the additive and what we're doing with it and how we're bringing it into what we do here. And it goes beyond that, from guys thinking about something as simple as how they hold their prints next to their machine to how they hold air hoses. They're always thinking of something that can be 3D printed or little trinkets or holders or whatever it may be. Everyone's super excited about it, and they like talking about it and seeing what we can do with this.
And that's great to hear. I love to hear when there's machinists and kind of lifelong career subtractive manufacturers that are getting into the technology and getting excited by it. That's half the battle. What can you tell me about some surprises that you've experienced based on your initial opinions of the technology now that you've brought it in-house? I mean, what are some of the outputs or the capabilities of the technology that have surprised you and your team?
So really, there's mainly two surprises that we had. The first is the surprise in how, not necessarily easy, but how adaptive you can be through Markforged University and the ability to learn the machine and learn the software and how user friendly it is. It wasn't something that was beyond capability of learning in the time that we took to learn it. And the other one was the strength of the parts that you get. I remember when we first unboxed it, we saw the reinforcement material, and we thought that was a great idea, but it also kind of gave you this idea that it's there because the parts aren't that strong. When in reality, we barely even use the reinforcement material because the straight onyx is strong enough to do anything that we're using it for.
Love to hear it. What can you tell us, some examples of some parts or applications that you and the team have been working on using 3D printing? What any in particular kind of general applications you can tell us about?
Yeah, so I mean, work holding and fixturing. The plate that I had showed you guys on the last interview that we did, that was holding the individual loops. That was the biggest one that we've done. That's the biggest time saver, as well as the cup checking fixtures and stuff that we use to check some of our coils. We're actually just now starting to kind of move towards maybe some mandrels for wrapping tubes and stuff like that. So we're definitely growing with it. I'm still not shy to say that we're new to this and there's a lot more to learn. But again, we're eager about it and we're pushing forward with this and we're trying to get as involved as we possibly can and incorporate it as much as we possibly can.
Well, Josh, it sounds like your eagerness and your desires to further incorporate the technology is contagious, and I'm sure it's running through your factory. What can you say to maybe someone that's on the call today that they're kind of on the edge of whether or not to get into additive. Might be something that they've been looking at for some time, but are just kind of looking for that sign or that push. What would be your advice or your your words that you would provide to them?
Don't second guess it. I mean, really, the machine is able to do a lot more than what you think it can do, and we see that every day. In fact, we kind of forget that we are the limiting agent to that machine right now. The other thing is that you can always get a hold of me. I'll gladly work with you. We'll print out some parts. We'll see what happens. And to me, a hands-on part is by far the most important thing that you can possibly get. So, and here at Tucker, we're able to work with whoever. We try to expand past just the induction tooling services. So we accept any and all calls.
Awesome. Josh will be sure to supply everyone with your information, and I know that your offer to help is sincere. Thank you for helping us out this morning and jumping on and kind of giving your background and your experience of your albeit short experience with additive manufacturing. Even in just such a short time, though, your successes and your learning has been pretty impressive. So thanks again, and we look forward to connecting with you again soon.
Thank you.
All right, we are now joined by Glenn Desmere of Induction, here to talk a little more about the benefits of additive manufacturing that he's experienced in his own career, as well as there at his company Induction. So Glenn, I'm going to pass the microphone off to you now. If you would, start by introducing yourself, your role there at Induction, and what you guys do.
Hi, thank you, Zach, for this opportunity. Very pleased to be here. My role at Induction is a product manager. Induction is a world leader in induction heat treating equipment, and I kind of do both product management and a lot of the hands-on design myself. So that's been very interesting. I have been at AM since 2014, in-house since this year, actually. And I've studied. My background is an undergrad in India. I did my master's in Ohio University here. I'm currently a teaching assistant for the online course through MIT, which is Additive Manufacturing for Innovative Design and Production. Great class offered by Professor Hart, Hayden, Rory, and Giorgio and Luke, who do a great job with it as well. That's what got me started into more detail with this. And I'm currently the product manager for crankshafts. Induction does a lot of induction heating, forging, etc.
Wonderful. Well, thank you for that introduction. Now, as you said, you've been involved in additive manufacturing since about 2015. What can you tell me about some of the applications and some of the uses of additive manufacturing that you have used since that time?
Since that time, primarily it was prototyping and some small projects that didn't involve anything going on production equipment. So, samples to show off to customers and showing off concepts to prove to customers or management itself, to have them done on VARs and service providers on the outside.
And Glenn, can you talk to me a little bit about why you initially started relying on additive manufacturing for a variety of different use cases? What was it initially about the technology that drew you to it to utilize?
To be honest with me, way back in 2009, I was also a presenter for the SolidWorks conference, which your CEO, Mark, was also there, and he presented the carbon fiber printer for the first time. And I'm talking about Greg Mark, and I was very impressed when I heard that presentation. I said, this is going to be something different. And I started getting involved with early FDM since then. And I knew the technology had a lot of potential. I started studying it. We didn't have much to do with AM at all at that point. So it was on a personal level, I started digging into it deeper and deeper. And I knew that this is going to make a big difference sometime in the future, but it kind of happened sooner than I expected actually, and I'm very pleased to where we are at right now. And with all the different technologies, we've still got a long ways to go, but we're getting there faster than I expected.
Great, that's great to hear. Now, you, as you said, have been using AM for a number of years, but just recently you installed your own system. What can you tell me about the process going from utilizing a service bureau or a service of some sort to print your parts? How did you incorporate additive manufacturing into your business and into your operation initially?
This was really a game changer. Now, Project Diamond, I would say, in collaboration with you guys, have done us a great service, not just to community, but in Michigan in general, and I believe to additive manufacturing as well. But since we got AM in-house, it's been a game changer. We've been printing a lot of things, and I've got the printer right behind me, if you can see, and we're not just doing it for us, we're doing it for our sister companies as well. We had a very unique implementation strategy that I can share as well later on how we did it, but we are doing things that we'd never dreamed that we'd be doing. So,
Glenn, you mentioned your implementation strategy. I'd love to hear what that was briefly there at Inducto Heat. How did you incorporate the technology into your everyday processes?
I think key implementation strategy, looking at it from a project management standpoint, additive manufacturing is not just another manufacturing process. This is a project management in a whole. I mean, if you look at the three components, you've got culture you have to deal with, you've got the soft skills that go with bringing about culture change, and the final thing is DFAM, which is Design for Additive Manufacture, that should play into this. Basically, it would be a Venn diagram with these three circles of culture, soft skills, and DFAM, and trying to get a nice balance between it to make things work. We started making like simple vice jaws and things for soft material that our guys could use. And then people started coming to me. That was some kind of a change in the culture slowly. And as we went along with it, people started, appreciating it. And then it was an easier point at that point in, doing some of it machining, some of it AM. So it took a while, but like I said, I'll take a couple more minutes on this. If you look at it, again, you have to look at AM from both a macro level and a micro level. What I mean is, if you look at a 30,000 feet from above, you first have to talk somebody into the benefit of AM and how you want to implement it. Then you have to plan on doing it. Then you have to actually do it, and then you monitor and control it. And then finally, check to make sure everything is fine. What I just described very briefly to you is the 5 process of a project management, which involve, your charter, planning, executing, monitor, control, and closing. So if you're not looking at AM from this macro 30,000-foot view and how to successfully implement it, it's not just taking apart and printing it out, then things become more acceptable. And that's basically the approach we took. So now that when we look at it is, we don't look at just printing a part that's a blueprint build. We try to look at it from a micro level and then go on the micro level I'm talking about is you actually have to apply DFAM principles, which is my passion and that's what I teach, to doing this. And even not only from the part level, but also from the print quality. If you have a big part that's complicated, I just go and print a small piece that could be a problem. And once I perfect it, then I put everything together and do that. So all of these has actually made me come up with parts that's really been impressive, which has now started the management from looking at it. And I've got comments that, this thing has already proved its worth in no time. Some manager said, I wish we knew this many years ago that these things are so accurate. I know companies don't come in and say, I'll give you things that make dowel hole precision. You can't do that because the machine may not be that precise. But we have to look at, how we use precision and repeatability to our benefit, use some compensation. I've been making dowel pins line up and work, very successfully, and even a lot of tooling that actually functions as good as machine parts. So that was key, basically, on how we approached the whole implementation strategy on being able to tackle a lot more things. Now I have people saying, okay, we have this problem. Can we use AM to do this? And I've got a bunch of examples that we can talk to if time permits. But yeah, it was key in how we implemented it to where we are today. And
well, great to hear, Glenn. Thank you for that overview. Now, you talked a lot about resistance, and the one thing to overcome resistance is the identification of benefits of the AM technology. If you could, you mentioned a few of them, such as engineering efficiency, time to market, failure identification early on in the process. Can you just tell me about maybe one or two of your, in your opinion, the most impactful benefits of additive manufacturing beyond just the cost and lead time savings that the process provides?
Okay, I would say the biggest benefit that we've been doing here is we've been pushing the limits with this technology. Okay, so we've realized the benefit of cost and time to market, but like I said, we're using it to do so many other things, not just as production equipment, but implementing it in the process itself to make it happen. So one example I can give you there is, we're, like I said, world leaders in induction heat treating, and we have our problems to deal with, especially when we have complicated parts that don't behave the way they should. So we had an issue where a part was distorting quite significantly, and anything would when you put so much of heat into it. So here again, we pushed the limits and came up with some kind of a fixture that would prevent this from doing that during the heating process. And it was pretty surprising as how well it worked. So I would say, in addition to those benefits of cost and lead time, we're actually doing things that we wouldn't have thought of doing, because now it's a matter of just me deciding how it's supposed to be designing it. It's cut out the whole middleman of everything, and I come straight to the printer. If I'm doing something, send it on Friday night, come in Monday morning, the print is ready to be tested. So it's cut out the whole issue of having to deal with getting approvals and doing things. When you believe you can do something, you have to go for it. You have to push the limits of this technology, and you have to be creative about doing it and actually do it. And the printer actually allows you to do that. I've been a fan of Markforged, to be honest with you, because the implementation was very successful. I've not had to call and talk to anybody about how I do this. The product has been pretty reliable so far, and I've been impressed with the accuracy of that as well. And I know there's a lot of good technologies and products out there, but for us, mainly, in addition to the improvements with lead time and cost, we've been doing things we wouldn't have done before, like the example I gave you, and many others, to be honest with you.
Well, Glenn, I appreciate you giving that insight. Last question here that I want to end off on. There's more than likely a lot of people in the audience here today that are looking into getting into additive manufacturing and in making that culture shift and that next step in investment in the technology. What would be your insight or advice to someone that may be in your position a couple of years ago, that is on the brink of bringing the technology in-house, but maybe hesitant for one reason or another?
I would say the first thing is believe in yourself and go do it. I know there's going to be a hard sell with management, especially if there's two ways. One is a bottom-down approach, or a bottom-up approach, or a top-down approach, where management gets you something and says, go with it. That's easy. But when you're starting off, where you have to convince a lot of people on doing it, you have to believe yourself and go do it. Get the printer, start working on things. The proof is in the pudding after that point. So my advice would be is, you're on the right track, go for it. My advice would be is, go get a printer. You will be successful. You will find things to do that you never thought possible previously, and don't rely 100% on AM. Be creative, use AM with, you're the engineer. You come up with the ideas and make it work. use AM along with standard inserts, standard things possible. And yes, the salesman can't tell you that we'll offer you this or give you that. There's limitations. They don't know what you're using it for. But once you get the printer, learn your machine. It's pretty repeatable. Learn how to convert, use the repeatability to make things more accurate. You can work with compensation. You can do a lot of things. So go for it and start printing.
Well, Glenn, this has been fantastic. I appreciate your time today. I know that everything you've said and your offers of assistance and cheering on is sincere. It's been great to see you implement the technology in less than a year. Since you had AM technology in-house, and the successes you've experienced and the benefits you speak of are nothing short of amazing. So, Glenn, thank you again for your time this morning. And I look forward to speaking again soon. Take care.
Oh, thank you, Zach. It was a pleasure. And as you can tell, it's been my passion, and I love teaching DFAM, and I love talking about it. And I've done it a few times, and it's been a very satisfactory part of my career. Thank you.
Thank you, Glenn. Last up, we are joined by Steve Michonne of Zero Tolerance. Steve, thank you for joining us. If you wouldn't mind, please introduce yourself and your company to the group.
Thanks, Zach. My name's Steve Michonne. I own Zero Tolerance, and we design and build plastic injection molds, and we also do molding in-house. And it is a pleasure to be here with you discussing this new technology.
Great to have you as always. Similar to the other two that we've talked to this morning, you're relatively new to additive manufacturing, at least having it in-house. Thinking back to before bringing it in-house, tell me about some of your opinions or some of your notions you had regarding the technology before bringing it in.
Well, I've had previous experience with hobby type 3D printers in the past, so I kind of had a preconceived notion of what these machines might do based on that experience. And to tell you the truth, it being in a shop that cuts hard steel, all kinds of subtractive manufacturing here, I did not believe I'd have a use for it that would actually hold up in a shop environment. So honestly, I can tell you, I didn't think it was going to be much use here at the shop.
Well, love to hear that, because I know where this is going to go next. Talk to me now, standing here today. What are the additional benefits, and what is, how has your experience competed against that preconceived notion? Tell us about how things have been since installing your first machine in-house.
Based on my assumptions, and I kind of do. I've done this throughout my career. Is I really kind of want to put stuff to the test and see really what can it do, and what's the benefit, and if it does work, boy, I want it to work as best it can. So my experience with it so far has been, I had a project I've been working on for about a year and a half before this opportunity presented itself. So I decided to design this thing on the weekend and through the week, and built a tool that would help us produce more parts safer and faster in our molding press, because of the operating temperature of the mold being dangerous for our operators. So I built a tool, and I ended up having it run. The first time I printed it literally, the whole assembly came together, and it made a world of difference the first week for us, our throughput, our safety, and a whole bunch of other advantages that we didn't even see. So I was happily proven wrong, which has been a lot of my philosophy. I think I know everything, and I really don't. So I've been pretty impressed with it, and I'm finding more uses for it all the time.
So you briefly mentioned some of the added benefits that you experienced with this particular application. Can you dive a little more into those? What are the benefits that you've derived from additive manufacturing that are beyond just the cost and lead time savings that everyone kind of gravitates to at first glance?
That's a good question. Well, the added benefits are not as obvious when you don't have it. So when you do have it, you start to see that, all right, so this solves the main problem I was after, but it also adds a safety level, ergonomics, it adds a throughput, and a turnaround time now for my customer when they have a shipping problem, which no one has shipping problems today. So a lot of the insight is seeing it from, I guess, from like a 10-foot view. So as I sit back and I watch this thing in our production area work, it added I guess a level of attention to the workers that, hey, now they've got something to do in their, I would say, sleepy time, where it would be they're waiting for something to happen in the machine, and now they don't have that waiting time. They have a productive input in the process, which just adds another level of attention to the process that we didn't have before.
So you mentioned, not really knowing the benefits until you got into it. There's, I'm sure, tons of people here on the call this morning and in general that are kind of on the edge of whether or not to jump into the world of additive manufacturing. If you were to be talking to one of these particular people, what would your advice be to them, and to those that are thinking about investing? Because it can be an investment, but what would your advice be to those people?
Making an investment in new tools is very it's scary, because you're looking for a return on your money. I'm a business owner. I know how it works. But I do know that the advances that are being made in technology and software and combining our old way of doing things with new ways of doing things, there's an advantage that you can't see, like I was saying, with our particular product. So if you're on the fence, I mean, I challenge you to put it to the test. Have someone print something for you if there's some tooling that you're struggling with, or just a spot in your shop that needs something, but you really don't have the time to put your normal tooling in place to solve that problem. My thought is, challenge it like I did, prove that it doesn't work, and you'll be surprised. From what we see, it works, and there's more applications than I can think of. So that would be my advice.
Sage advice indeed. Steve, thank you for joining me this morning. You really added a lot to the presentation here this morning, and I look forward to working together more into the future and seeing what these great ideas are that you have in mind. Thanks, Steve.
All right, thank you, Zach.
Thank you once again to Josh, Glenn, and Steve for joining us this morning. It was great to have each and every one of you, and your insight is always fantastic. We are now going to pass the mic to Nick Sunday, who is Markforged's additive consultant, to dive deeper into the conversation with a great presentation. Take it away, Nick.
Awesome. Thanks, Zach. So let me just bring out my presentation real quick and get going. Awesome. So good morning, everybody. While this thing loads, I'm Nick Sunday, and we're going to be talking today about, let's see if this loads. Come on. 2 seconds. Let me just try to share that again. One more time. Come on. Perfect. There we go. So today we're going to be talking about thinking about sort of business impacts of additive manufacturing beyond sort of maybe the surface level things, beyond, just thinking about just cost and lead time improvements that you might be looking at or thinking about when you're comparing sort of your traditionally manufactured tools, parts, projects, whatever, to something where you're actually 3D printing those tools, parts, or projects. And so just before we really dive in, just a little bit of an intro. I'm Nick Sunday. So I've been with Markforged about 7 years now, actually a little over. I'm a mechanical engineer by training and experience, but really what I've been doing over the last, especially about 5 years, is working with industrial manufacturers to really focus on where additive manufacturing can have sort of the biggest impact in their operations, and then also helping them learn to and assist with designing for additive manufacturing. So actually going out and designing for the process, which I think is a big thing. Oh, sorry, I'm getting a little Zoom toolbar. So designing for the process. So a lot of times, there's this perception of, oh, I can just, take something I've already been producing and just 3D print it. And really, the best parts are always designed for the specific process. And this is probably true of anything you're doing. And so I help a lot of our industrial manufacturing customers across the US and also throughout the world really figure that out. So the main point here I want to make today is that if you're only really focusing on those cost and lead time sort of impacts of additive, right? So you take a look at a part and you maybe get a quote from a manufacturer and say, okay, well, it's going to cost you this much material, and this you'll be able to produce it this fast. You're really missing out on the bigger picture or the bigger sort of impacts that you could be making in your operations. And so let's talk about those. So there's obviously every manufacturer is different. Every manufacturer has different challenges, different economics things, different, especially recently, supply chain and logistics issues. But 3D printing, at least the way I've run into it, really seems to make an impact in sort of three main areas in industrial manufacturing. And so we'll talk about these a little bit. And it's really to drive value in reducing sort of your manufacturing process costs. We'll talk about that. Helping you optimize some of your supply chain, especially around things like tooling, and also giving you the tools to increase your speed to market with either new or existing products. So we're going to talk about all three of these in different ways today, but these are sort of our high-level drivers of value that 3D printing can work towards. So we'll use these kind of as the context, but then we're going to talk about some more very specific examples. I also want you to think about sort of this idea of sort of immediate or direct versus operational benefits. And what I mean by this, actually, I'll go into this in a second, but in general, it's easy oftentimes to see the immediate benefit. I realize this is a little bit of a maybe silly slide, but it's easy to see what's in front of us, the immediate benefit. Oh, let's just focus on that. But a lot of times those operational or those organizational benefits really are a much larger piece of sort of the impact that additive can have in you. And so let's talk about what those two are right now. So like I said, immediate benefits are things that are, you immediately can see. So oftentimes this ends up being cost and lead time. So for example, we have this is a part actually that we did with Stanley Black & Decker to prove out sort of what additive could do for sort of their spare parts business. And so the part on the left was a traditionally, casted and then had some machined parts added to it at assembly. And then the part on the right was, specifically redesigned completely from the ground up for our metal 3D printing process. And so, you look at it at a service level and it's okay, well, there's a big cost reduction in 3D printing it and there's a big lead time reduction in printing it. That's awesome. So why don't we just do that? And what we'll find is that's great. But when you look at a lot of those immediate cost and lead time benefits, a lot of times it's sort of, you can get that benefit, but only every time you print the part. So if you want more of that impact, you got to print more parts. And that can definitely drive impacts in your business. What we usually see is that if you can improve a process, usually process improvements are going to drive these larger operational benefits. And a lot of times that'll give you a point where you can, print one part once, or maybe print a couple iterations of one part, but then put it into service. And that part is then going to continue to drive and deliver larger recurring impacts for your company. So we'll see this throughout the next couple sort of topics, but really thinking about those operational benefits, or how can you sort of impact process and ongoing process, is really where a lot of times we see where a lot of these bigger and more significant dollar value impacts are coming from. So a couple things we're going to talk about today. We'll talk about cycle time and throughput, supply chain, things about how we can, potentially help with inventory holding costs, efficiency, both on your engineering and sort of resource utilization side. Talk a little bit about line changeover and some of the sort of those when you're moving back and forth between different product lines. And finally, we'll talk about some EHS benefits, and also how additive can really drive an innovative culture shift at your company. And that's how, honestly, that in itself is also a massive impact in the way that your company can operate. So without further ado, let's kind of dive into some of them. So the first one I really see a lot of times is using additive to kind of drive faster cycle times or drive throughput. So typically, there's two main effects I see here on productivity. So one is to just help you increase your production speed. So if you can use additive to drive production speed, whether it's tooling, whether it's some sort of other process impact, now you haven't really done anything else other than speed up your production, and you're getting more productivity out of the same equipment in the same amount of time. The other huge one is to cut out scrap or increase your yield. And that's something that you don't change anything about your process other than you're just not scrapping as much parts, or you're increasing the sort of overall productive yield out of a process. And both of those can really obviously have massive improvements on recurring cost impacts to your process. So let's talk about a few of those. So the first one a lot of times is with end of arm tooling. If you're doing automation at all, or if you're doing any sort of either mechanical automation, robotics, anything where you have grippers, tooling, etc., that impacts the payload of your automation system. So a lot of times you'll see a lot of people starting to look at printing end of arm tools, robot grippers, things like that, specifically for the lightweighting. So if you can lightweight these things, you can potentially, if you're building up a new line, you may be able to go from a larger robot to a smaller one, and cut the overall cost or capital equipment costs of that new line. Obviously, maybe you're not going to go from this large of a robot to that small of one, but if you can drop the sort of overall robot size that you need, or the payload requirement that you need, because you're no longer putting as much payload percentage into heavy hard tooling or metal hard tooling, but 3D printing it instead, you can significantly decrease the capital equipment costs of putting a new line. On the other side, if you can drop the payload weight of your tooling, you may also just be able to run your robot faster. So there's sort of a capex reduction if you're putting in a new line or building up a new manufacturing process. But there's also just straight up that you can run a process faster potentially if your sort of tooling weight is limiting how fast your robot's able to move. So either of those two impacts can result in a cheaper process economics or faster productivity, faster cycle time. And we see that a lot in a lot of industrial manufacturers that are doing automation. And when we're talking about cycle time, there's also a couple of the things that you should be thinking about how additive can make an impact here. So for instance, a lot of 3D printed parts, especially ours, are going to have like a honeycomb, or by default will have a honeycomb, lightweight infill in them. And this actually doesn't really reduce the strength very much, but it significantly reduces the weight. So if you're, going through a process where you have heat and cooling cycles and you're sort of waiting for that part to heat up or cool down, especially with your tooling, a lot of 3D printed parts are going to have, lower thermal mass. They're going to use less material, so they'll be able to heat up and cool down faster. Or you may be able to design in, channels to make it easier to heat up and cool down, stuff like that. That's going to allow you to speed up those processes and get more products through your system. We also oftentimes see this with sort of lightweighting hand tools, and we'll talk about this a little bit more in the EH&S section, the environmental health and safety section. But you may be able to lightweight hand tools, make it easier for your operators to move things around. And in general, you're looking for ways that you can have a lower impact due to your tooling on the overall process speed. So if you're thinking about your own manufacturing operations and you're looking at, okay, well, how could I speed something up, or where's things being slowed down? Think about, are there impacts from that tooling you have on the overall process speed? Cool, and I want to show a real quick video. Steve was talking about this earlier in the interview Zach did. But this is sort of an example of some faster process speed due to a hand tool. So this is being able to increase your cycle time just with a tool, a 3D printed tool that's going to make it easier for an operator to run a process. So let me just run this real quick. You can see a side-by-side comparison, whether if you're having to manually load this thing, manually load this overmolding tool one at a time versus having that tool that just loads all of them at once. You can see we got about a 4x reduction in process speed just by having that tool load all these at once. So that's a great example of now we've reduced our cycle time, and the overall process productivity is much higher here. Okay, so cool. So let's talk about more of those environmental health and safety benefits as well, because there's kind of going along this idea of potentially cutting your cycle times or reducing your weight and making sort of things easier for your employees. There's a lot of ergonomics and potential benefits there. So really some of the things that we see across the board in manufacturing when you're starting to bring additive to employee tools, operator tools, et cetera. Increased ergonomics. So you have a sort of much, or additive gives you the ability to create much more complex, much more tailored, ergonomic parts. So you can really dial in the sort of ergonomics of your tools, make it easier, make things more custom, more, lighter, easier to handle. And that's going to drive up ergonomics, which then leads, oftentimes we see this across the board, there's potential for reducing sort of injury rates, especially repetitive strain injuries and sort of fatigue injuries or things related to heavy tools. We're able to see a lot of industrial manufacturing customers drive better tools and better outcomes for their employees just by sort of rethinking the way they make some of these tools. And then the nice part about this is while you do those two things, you also as a company get faster cycle times a lot of times. So especially if you're, think about, you have an operator that's lifting something heavy for an 8-hour shift, but now you cut the weight significantly down of that tool, they're going to get less fatigued over the course of their shift and have a much more consistent sort of cycle time with less fatigue, less propensity for injury throughout that shift. So it's not only great for your operators and your employees, but you're getting a much better sort of consistent productivity out of those things as well. So next, let's talk about sort of supply chain and logistics. And I know that obviously over the last maybe 1.5 to 2 years, this has become sort of more front of mind for a lot of different industrial manufacturers and supply chain people. So we obviously can't, get the boat out of the canal, but what we can do is think about, at a factory level or a plant level 3D printing. If you're doing some of your tooling or able to 3D print spare parts or replacement parts or things like that locally, you're going to be less disrupted by sort of supply chain breakages and supply chain disruptions, and you'll also have more consistent sort of forecasting and ability to respond to sort of local challenges that you need. And beyond that, you're also going to be able to potentially avoid things like the costs and logistical hassles of importing or exporting tooling parts. We see this a lot of times when someone has a CNC machine that only gets parts from Germany or from China or somewhere, and anytime something breaks and they need to replace it, now they have to deal with those sort of logistical hassles of getting parts. Anything around customs, tariffs, just general supplier issues. Obviously, we've seen that over the last couple of years. You're going to be able to eliminate a lot of that friction and a lot of that sort of hassle out of your operations if you can sort of offload some of that type of work, especially spare parts and that tooling, down to the 3D printer in your facility. So think about sort of what's the costs associated with being able to drop that out of the equation for you. That's where the impact comes in. So another example out of one of our sort of Project Diamond customers was this company, Unique Short Tree, who does a lot of sort of repairs and replacements for different, well, in this case, it's a slingback furniture. And so they had this issue where the supplier was, had a huge delivery time or a 2-week turnaround time just to get some of these small little caps for them. And Unique Short Tree kind of prides itself on being able to turn around, work for their customers incredibly quickly. And they were basically just going to have to be sitting with this customer job for 2 weeks, for a $2 piece. And they have a bunch of these different caps they gotta build. They were able to turn this around in 10 minutes and 79 cents by just printing it in-house. So rather than having to deal with this extended supply chain, which was getting disrupted, with the COVID pandemic, they could just do this in-house, design it. You'll notice that they did have to change the design a little bit. So this is the design for additive component of this. But they're able to immediately now respond sort of and bring that, the agency is brought back in-house to them. They're able to actually, drive forward that job, solve this customer challenge, and then, delight their customers and get back to them without having to rely on external sort of third parties, supply chain issues. So there's another good example there. And so the idea is that, beyond just a single site, you also, especially if you're a company that has, distributed sort of facilities or operations, what we see a lot of times is, companies will put a local 3D printer and then be able to distribute those digital designs for any sort of common parts, tools, work holding, et cetera, across to their facilities. And rather than having to deal with the shipping and sort of logistics of getting those tooling from one centralized location to different local plants, they can sort of just send that, digital design over the internet and have the localized plant just produce it in-house. So it really simplifies a lot of that, friction around supplier issues, and you no longer have to worry about, can that logistics provider get that part to me? It's, well, I know I can have a very targeted, deterministic when I can make this in-house because I can just send to the printer. So another thing to kind of think about with additive. Another thing to think about is in more inventory. So inventory holding costs. So if you are holding, especially we see this a lot with industries that are holding significant amounts of tooling that they're not necessarily using every day, but they have to kind of, it represented such a capital expenditure or a fixed cost to that manufacturing process that they're keeping 5, 10, 15, 20 years of tooling around just in case one of their customers decides to order something again. And this is especially common in the sort of casting and foundry industry, but there's a lot of other examples as well. So if you're holding all that inventory around for 5, 10, 15, 20 years, longer, whatever, in some cases, you're being taxed for that tooling inventory. Even if you're not being taxed for it, you may have facility overhead because you're having to maintain a larger warehouse just for all this tooling that doesn't get necessarily used all the time. You are paying for the labor to run that facility. And so you're spending a lot of time and effort on holding inventory that may not actually be creating value for you, rather than the alternative, which is, especially with tooling, if you can 3D print those tools on demand, and that you're probably not going to see that job for another 10 years, you can scrap that tool and just keep the digital files for it. And if that job comes back up in the next 10 years, you reprint that tool, but you're no longer sort of holding this inventory around, and you're reducing this sort of drain on your business by no longer having that. So another thing to look at is what I kind of look at is engineering efficiency, which is sort of like, how can my engineers design something and get feedback on it quickly, so they're not waiting around and kind of context switching a bunch between various projects. And so the easiest way to think about this is if we look at kind of the different inputs or different sort of time costs to doing something like, let's say you're outsourcing your tooling to another shop, right? So you're always going to have your CAD, but now you got to build a drawing for it, go through an RFQ process, maybe engineering review with the supplier, go through the backlog, then they actually machine it and deliver it to you, right? And so that full sort of machining production time is one design iteration. So a lot of times we see that's 2 to 4 weeks for a lot of manufacturers, where they send something out, 2 to 4 weeks later, they get something back, and their engineer can then test it. And that's a lot of time to go from when you design something to when you actually got it back and you can test it and see, hey, did that work the way I expected it to? And so, in that meantime, that engineer's gone off to other projects because they're not going to just sit around for 2 weeks. So there's a big switching penalty too on the actual engineer, because now once they finally get that part back, they got to now think about, well, what did I do 2 weeks ago, or what was the the stuff that I designed 2 weeks ago. So with 3D printing, you cut out a lot of that sort of overall time, right? You cut out you don't need to make a 2D drawing from your CAD. We start directly from a 3D model. There's no sort of RFQ and engineering review and backlog process with an external supplier, because you have the whole thing in-house. You really just, once you're done with the CAD, you're going to send it to the printer. So there is still some printing time, and delivery's basically gotten, you probably walk to the printer and pick it up. So your design iteration time has significantly been reduced. And this is where it gets really important for your sort of thinking about how your engineers are focusing. So in that same amount of time that took you to get one sort of machined outsourced tool, you can basically get a couple different iterations of that same tool. So there's two options here. One is that you're either producing that same tooling in a significantly faster, significantly shorter amount of time, or in that same amount of time, you're getting a significantly more mature design because you've gone through 3 iterative rounds of testing and feedback throughout the whole thing. And the best part for your engineering resources is that your engineers and designers aren't context switching every couple of weeks because different projects are coming back. They're able to really focus and really preserve that focus and preserve what they were thinking about and preserve sort of how they were going about solving that problem. And they're not context switching between different projects all the time, because they can actually sit down, focus on a project, get feedback on it quickly, and then kind of either finish the project up or continue iterating. And let's see if this works, but this is one of our customers in the sort of window and door manufacturer, talking about one of their engineers talking about some of the tooling they were able to make for their production floor. I'll just let him speak for himself.
This fixture to machine traditionally would probably cost 5 times as much and take 2 weeks to manufacture. I printed it in a day and they were able to use it that same day.
Cool. And so Caldwell makes all kinds of these windows and doors and different sort of hinge mechanisms and things like that. And so he was able to actually, we see this all over our customer base. He was able to actually, really quickly solve a problem and actually see it in action later on, that same day or the next day. And if there's feedback from manufacturing, he can adjust and then solve the problem and move on to the next thing. Okay, so just a couple more of these sort of deeper impacts to be thinking about. So another one's resource utilization. This one's I'm focused more at the actual machine resource utilization. So if you look at a example from a production facility, in this case, it's maybe a motor manufacturing facility. You have obviously the production part, and you have or the production, the thing you're making, and you have some of the tooling that that part is resting on, which is specifically in this case, this blue nylon sort of fixture blocks underneath this thing. And I realize maybe with an automotive manufacturing facility, it's probably not accurate, but a lot of smaller companies, and honestly, even some big ones, you may see that your tooling, your R&D, all of those things that you need to machine are going through a similar shop as production parts are going through. We actually saw this with some large automotive customers where it wasn't their production parts, but it was all of their rework parts that were still production parts were going through the same shop as all their tooling was. And so you get into these like sort of prioritization, races where production always takes precedent. So then you might be getting behind on tooling, and eventually you need to, get caught up on tooling, which means, your production gets into a backlog. So you run into this sort of resource competition thing. But with 3D printing, you can oftentimes isolate some of your tooling to go down to the printer and leave your production parts to go through the sort of more expensive, sort of specialized, machine equipment or whatever it is that you actually need to send those production parts through. And this is a lot of times where you see customers or manufacturers that are using 3D printing or additive for tooling. They're able to sort of establish these swim lines and really clear a lot of these backlogs and clear a lot of these sort of production hurdles, because they're no longer sort of competing for resources between production and their sort of tooling and operations side of it. And along those same lines, we also can look at sort of line tool up for new product introduction or just sort of switching over lines and sort of that changeover efficiency. So if you're thinking about your existing operations, if it's taking you a long time to actually initially tool up for a new product or new product line, you oftentimes can do a much faster job of initial tool up with additive. So rather than waiting around for all those outsourced tools, all those supplier challenges to actually get the tooling you need to set up your line, you may be able to do that a lot faster in-house and actually get that manufacturing process up and running a lot faster, which then allows you to get to market with your products a lot faster. The other side we see this is a lot of times manufacturers have problems with changeover, where when you're changing over that line, it takes a couple days to actually switch over a line from one product to another. And a lot of that is usually oftentimes due to manual or semi-manual calibration, machine tool sort of like calibration and really getting those different manufacturing lines specific to that one product. So if you can print jigs, fixtures, calibration devices to help sort of make that changeover faster, once again, you're going to get to market faster and you're going to have more time and more productive time where your manufacturing line is going to be up and running. And so just a quick example here, we had a customer that was feeding a robotic sort of assembly cell with product, and there's multiple different products, multiple different sizes that go through that cell. So every time they switch over and change over that production cell, they had to realign. You can kind of see in the bottom of this picture, there's a bunch of sort of guide rails. They had to realign those guide rails every time for that product. And that could take 4 to 6 hours, because before, these guide rails were basically all bolted into a bar. So an operator had to manually unscrew all of those bolts, realign the guide rails, and then manually screw those bolts back in. And so they actually 3D printed a better solution to this with these quick pull pins, where they could basically just pull a bunch of these pins, adjust it real quick, and then pop the pin back into a different position. You can kind of see they had some numbering back there on some of those different locations. And it really dropped this sort of changeover time from hours down to like, I think it was like 15 minutes or 30 minutes or something like that. So now every time you're more agile every time you want to change over manufacturing lines, and you're also spending a lot less time and effort actually manually configuring or reconfiguring these different production lines. So this is a good example of where sort of additive speeds up that process side of things. And then the last one we really kind of see a lot of times is to fix what I like to call cardboard or duct tape engineering. And so this is, oftentimes becomes a problem during changeover or during tool up, because if you, had an operator, fix a problem temporarily with something like, hey, I tape some foam here to stop a product from hitting something, or I, manually readjusted something. When you change over the line, a lot of times you don't necessarily know why that solution was done, or it's sort of like a tribal knowledge of, that one person knew why it was done, but really wasn't, documented well or anything like that. You oftentimes run into issues where, all of a sudden you change over that line and now there were problems because we didn't expect to see that issue. So 3D printing solutions is nice because you get it into CAD, you actually, have a documented sort of part. And then you can also really easily design in things where it's like, okay, well, I know that, when I'm running one product line, I am in position 1. And then this 3D printed fix or this 3D printed improvement to my process line, when I go to a different product, it's going to be in position 2. You make it much more deterministic for some of these sort of like optimizations and tweaks and tuning for different manufacturing lines. We actually have a good example from, once again, one of our Project Diamond customers out in Michigan, Valentine Distilling, and they had these brushes. So their bottling line is, I think, an Italian bottling line or something like that. And so it was sort of designed for one specific type of bottles. But Valentine runs a bunch of different types of bottles for their different products through this line. And so they have to adjust sort of these brushes to help reapply or ensure that the labels on their bottles are properly applied. And the brushes need a different position sort of with every bottle. So this, before they had sort of a duct tape or some sort of solution to kind of hold this together, but it really wasn't deterministic. It wasn't easy to adjust. And so it adds time consuming and labor work to actually configuring those lines when they're switching over and changing over between products. And so you can see, these are fairly simple 3D printed parts, but they're incredibly effective because they allow them to like perfectly dial in every, for every different bottle they run through, they can easily dial in the geometries of these different brushes and make sure that, it's properly adhering these labels. And then also they're cutting out that potential for rework. So when we think about, going back to the sort of productivity side of things or cycle time, they're no longer, or they're reducing the amount of rework that they could possibly have running through their line, and that leads to better productivity, and lowered manufacturing costs. All right, and then the last one I want to talk about before I do a quick little case study, and then we'll finish up, is culture shift and really transforming the way that your business kind of thinks and the way your operators, engineers, and employees really kind of contribute to the company. It's a bit of a like a snowball down a mountain kind of analogy here. So by having 3D printing in-house, it lowers the barriers to taking an idea that someone had and actually implementing it, right? So you're not having to send a part out to a shop with all the overhead that requires. You're able to do something quickly. You're able to actually test something in-house rapidly. And so it kind of starts this flywheel of, and I think it was mentioned kind of in some of the earlier interviews, where you have someone suggest an idea, you can have someone actually design something for it, test it, print it and actually test it. And all of a sudden, everyone around them realizes, oh, wow, they were able to actually solve a problem really quickly or test an idea really quickly and get feedback and figure it out. And you have more buy-in from your employees, from your operators, from your engineers, because now they realize, oh, well, actually we can solve some of these problems, or we can at least do something to address some of these challenges quickly. And so that starts to lead to greater mind share in the company when more employees are contributing to, thinking about different ideas or how they can improve different, operations or things that are frustrating to them. You get better ideas, you get more ideas, and it just sort of continues this sort of flywheel or this, snowball down the hill of just sort of enabling continuous improvement or empowering continuous improvement in your operations. All right, so I want to do a quick sort of application case study on one of the tools that Steve was talking about earlier, which is this claw sort of hand tool for helping load those parts into that overmolding process. So I just want to take a look at just a quick look at we've talked about a number of these different sort of deeper impacts versus just obviously the cost and lead time of producing a tool like this. But let's take a look at some of those deeper operational impacts. So first, we talked about cycle time. So the first thing that's probably the easiest to obviously look at is the cycle time of being able to just put those parts in really quickly, which I think was like a 4x or so faster reload time, maybe more. So you can basically pop all the old parts are ejected, or the finished parts are ejected from the overmolding machine. You open the machine, you pop all of those parts in at once, and you're good to go. So we've already improved the cycle time there. But the other thing that we didn't talk about yet is that those operators can then load that claw in parallel while the molding process is occurring. So rather than slowing down the process to load 8 parts in manually while the process is sort of down, they now can load that claw while the machine is actually working. right? And then so then they just pop all the parts in during machine reloading. So let's show a quick video of that, right? So these parts can be loaded, as you're about to see, mid forming cycle or mid injection cycle or overmolding cycle, right? So the operator has, as Steve mentioned, the operator has something to do, or they're also, while they're doing this, the process is just continuing. So it's a little bit easier to do that. And then when you actually come in there to load it, it's a quick, you put everything in, you ensure that they're snug, and then the process continues. So it sort of parallelizes that process, which all leads to faster cycle time and better economics around that process. And second one, he talked about operator safety, right? So this is our environmental health and safety again. The operator's avoiding having to potentially contact that hot tooling surface. It's not super hot, but it's definitely still something where it's nicer for the operator to not have to touch or potentially touch the mold. So it's, you know, a better loading experience, but it's also going to improve health and safety, employee morale, engagement, et cetera. And you can, and you can see, you know, you're just touching that, or you're pressing those parts in just with the claw now. And the last part about this is what we just talked about, which is on employee engagement, is, you know, employees can see those types of impacts, right? Engineers and operators can see those types of impacts and realize, oh, so, you know, that was a great idea. I have another problem that I think this would help with. So I can drive continuous improvement myself by suggesting those ideas, right? So it's employees are more engaged in the process. You have, you know, your operators and technicians that are actually operating machines can feel be more empowered to be, you know, similar to owners in the company and its success, and you know, help contribute to that sort of continuous process improvement. And that's like really the sort of pinnacle of you know, continuous process improvement is when you have, you know, widespread buy-in engagement with that process, rather than it being one or two people that are running the whole process. If you have, you know, employees across the board spotting improvements or areas for improvement in your operations, you're now able to significantly or do much more significant improvement across those operations. Okay, so I talked a lot, but I'm done now. So any questions around this kind of you know, thinking about some of these deeper impacts or these additional impacts?
Perfect. Thank you, Nick. And I'm just going to reiterate that the Q&A is open, so feel free to type in any questions you have. But to start, I have a few questions. So that last case study with zero tolerance was really interesting. If someone's trying to find those kinds of opportunities in their plant, where do you recommend the starting point is for them?
Yeah, so every manufacturer is different. So, you know, I can't recommend necessarily specific applications. And this is why we've kind of talked about, you know, a lot of these sort of categories. But one of the things I like to do is actually, you know, a lot of times we'll walk through a production line, a manufacturing line with, you know, the people running that plant. And we'll run through it in sort of logical order or chronological order. You know, we'll run it from the start of that process all the way through the end. When you're looking at some of these areas for improvement, especially in sort of waste reduction or process improvement or, you know, scrap reduction, I like walking through the process from start to finish and then starting to think about the challenges from finish to start. So looking at it backwards. And the reason, you know, this probably makes a ton of logical sense, but the reason is when you have scrap and waste right at the end of that process, you're not only wasting, you know, that components or you know, work in process product at that point, you're also wasting all of the upstream time that was spent actually making that part, right? So it's not just the immediate process there, it's also anything that went upstream of that was all wasted time as well. So if you start at the end and kind of work backwards, you know, that's a good way to sort of focus on the highest impact and the biggest opportunities for cost savings and process improvement. So that's one area that I like to look. And then I also like to just sort of consistently ask the question, like, you know, what is this costing you? or what is the biggest frustration? What is keeping you up at night, especially from a process perspective? And those types of kind of things are usually a good starting point to at least address, well, what's the root cause of that? Why is that problem happening? What is at its core, what is causing that issue? And then seeing if you can address something in that sort of root cause with additive.
Okay. Yeah, that makes sense. So you mentioned a couple impact areas just in that last statement. Where do you think the biggest common opportunity for manufacturers are in all of those different ones? I know you mentioned like 3 or 4.
Mm-hmm. I think there's a couple things that are sort of highly useful. I think almost everyone is doing some level of work holding or fixturing or assembly, and especially things that don't require a ton of extreme high forces or anything like that. Like almost across the board, fixturing in general, whether it's for assembly, right, for sort of work holding, whether it's process transfer sort of between 2 different processes, any of those sort of work holding tooling, like I see that all the time. That's a pretty common manufacturing application across the board. And then I'd say the other one is to look at things that you don't currently make in-house right now, which means that you have to you're reliant on sort of external vendors, suppliers, supply chain to get those parts. So, and realize those are 2 different things. So those are sort of 2 main areas or 2 different kind of filters to look at. And then I think there was a good question that came in. Let me just see. What are some of the most common customer objections related to change from using traditional subtractive manufactured parts over to additive manufactured parts? Yeah, so that's a good question. So the biggest thing is I would say the biggest thing is people are used to the material properties, mechanical behavior, et cetera, surface finish, what have you, of a traditionally sort of manufactured part, right? They have expectations, they have intuition around how those things work. So, one of the probably the biggest objections at first is, well, it's different, right? And maybe it's, I don't know if I can use that. I don't know if my customer would accept that, et cetera. So that's a fair point. It's a fair question. And it really depends on what you're focusing on. So I look at a couple filters here. One is to reduce sort of the functional requirements. So a lot of times parts that are going to your end customer probably have higher expectations around, surface finish and what it looks like, et cetera. Right. So it's the same thing as, you wouldn't buy a computer and then, realize it had a 3D printed cover and it didn't look injection molded. You probably would have a lot more sort of, you have higher expectations for what that looks like. If that's manufacturing tooling, you probably don't really care what that looks like as a tool, as long as it, is strong enough, it gets the job done, et cetera. Right. So I start, I guess, when I'm, especially early on when someone's thinking about additive, some people are like, well, I know that's a guaranteed win. Let's move on to something that's tougher. And actually, I kind of switched that around. It's like, well, if it's a guaranteed win, let's go after those guaranteed wins, get all of that low hanging fruit first. To start with those sort of applications which have maybe the least requirements, but still have major cost impacts or major, sort of economic impacts. Get those, right? Start with the easiest things first, because that's basically free money. And then the areas where you need to have sort of additional, testing, R&D, et cetera, maybe they have higher certification requirements, et cetera, save those for after you've kind of gotten all that low-hanging fruit. And then the second part of that is also due to, the second biggest objection is oftentimes, especially in a plant or in a manufacturing process itself. Oh, what happens if this thing breaks? There's a safety requirement, et cetera, which is once again a great objection, and it's a fair point. So in those cases, I look at it, from a risk tolerance perspective, right? So thinking about where, there's parts that obviously they cannot fail because, there's life and limb, there's potential for operator injury. And then there's parts where, the forces involved are never going to make that part fail, or it's, contained within a CNC machine, or it's, whatever's the answer, or an enclosure. So there's a spectrum of sort of risk tolerance for different parts as well. And the same thing kind of goes from there. Start with the ones that have the least sort of requirements, or the least, there's the least risk associated with it failure. Gain some confidence with the process, gain some confidence with the actual technology, the parts, and also you have less risk. And then as you become more familiar and comfortable with it, move up that chain a little bit while safely testing, in a appropriate environment along the way. So, I certainly wouldn't recommend people 3D print everything. And I certainly wouldn't recommend people immediately stop, subtractively manufacturing stuff and switch over to additive. It's really a process, and it's a learning and a journey as you kind of, understand where your unique operations and requirements and applications, et cetera, which ones make sense with additive and not.
Perfect. Well, if anybody has any other questions, feel free to type them in now. I just have one last one. So you mentioned the cultural shift at the end of your presentation there, and that's something that we've been seeing with a lot of our manufacturing members, primarily this past year with everything going on. So I guess my question is, personally, what have you seen for the customers that buy these 3D printers? Has it almost started that cultural shift? Has it been easier? What does that look like from your point of view?
Yeah, so I think there's two aspects to it. I do think that quite a lot of stuff, trickles down from the top in terms of perspective. So if you have, executive leadership that's promoting a culture of, let's find a way to do something, or let's find a way to say yes to an idea, or let's find a way to test something, I think that obviously trickles down and sort of empowers and encourages, individual contributors to go after and chase things, right? So if people know that there's a safety net of, they're not going to be blamed if they test something that goes wrong, but they're supported in obviously safely testing things. And that's, entirely unrelated to, or regardless of additive or not. I think that is a good starting point to building that culture. But with additive specifically, I think that it's more of an organic culture shift or business transformation where, people start to realize that they have more ability to make an impact, make change, actually sort of make their ideas a reality. And then, I think a lot of businesses then realize that they can beyond just, their employees being able to make ideas, they can get sort of secondary benefits from that. So for instance, we had a customer out in California that, they make really cool technology, but they're in kind of a little bit remote area. So they're not near a city. So it's a little harder for them to hire sort of new grads, and their technology is interesting, but it's not necessarily like super sexy or anything. So it's a little bit harder for them to hire because it's just not, it's harder to sort of gain, or to market it or advertise it. And they actually use additive, and the fact that they can, encourage their employees to test things, et cetera, as a hiring kind of perk or a hiring strategy, where they can talk to new engineers coming out of school and say, hey, by the way, if you have an idea here to improve something or to test an idea or whatever, you can do that because we have a 3D printer down the hall. And as long as we're not doing something for production work, if you have an idea, like we can have you design it, we'll do a design review, and then you print it. And he was saying, that their CEO was saying that, like, before they had the printer, it was like, well, we got to send that out for a 4-week lead time on a CNC job. So unless that idea is like phenomenal, and it's definitely going to be a great idea, like we have to kind of maybe think about, does it make sense to actually spend that time and effort testing something? Whereas now it's a completely different sort of transformed culture. We can say yes to a lot more ideas, and there's a lot more buy-in, and we can use it as a recruiting tool.
Yeah, and that's a great answer. That's what we've been seeing a lot with some of the Project Diamond companies. And I can even say we at Automation Alley have a Markforged printer, and we have about 5 or 6 of our employees that went through the Markforged University, and they know how to 3D print things. And it's really cool to see what things even just us as a membership nonprofit organization are able to do. Thank you so much. If anybody else has any questions, feel free to send them my way and we can get them to Nick and Zach so they can answer them. But thank you both for your presentations today. We really appreciate it. And everybody be sure to tune in to our next Tech Takeover on August 25th about cybersecurity risk and resilience with Comcast. So again, thank you, Nick, and thank you, Zach, and everybody have a great day.
Yeah, thank you all. Have a good one.